Hello students, this is lesson U5A04b. In this lesson we are going to go over the side-splitter theorem and the triangle-angle bisector theorem. So hopefully by the end of the lesson you should be able to say, I can find the lengths of segments using proportional relationships in triangles resulting from parallel lines. Let's take a look. So students, these were the theorems that the top row there, okay, were the theorems that we had gone over in lesson U5A04a. The new theorem for this lesson is shown on the second row, which is the triangle-angle bisector theorem, which states if we have a line segment that's bisecting a particular angle in the triangle, in this case angle x, then the result is we're going to have a base that's partitioned, okay, into some part, okay? As a result, the proportion between the left leg, and the left partition will be equal to the proportion set by the, on the right side, divided by the right leg, which simply just states A over B is equal to D over C. Again, the description is more confusing than just seeing the application of this, right? So I have A over B is equal to D over C. All right, so let's take a look how we can go through this, or applications of this. So the question here says to find out what AD and CD is if the following information is given. I encourage you to pause the video and to try this out on your own. Students, hopefully you had some time to think about this. So let's go through and apply the triangle-angle bisector theorem. I know that AC is equal to 13. Well, how do I know, first of all, that I need to apply the triangle-angle bisector theorem? That's because this information here is given. I'm told that angle ABD is equal to angle CBD, so I am going to indicate that as such. So angle ABD is this angle over here. It is indeed congruent to angle CBD, which is this angle over here. I know that AC is equal to 13, which is this entire length right here. So that's 13. And then I know that AB is equal to 10, and CB is equal to 16. So according to the triangle-angle bisector theorem, I'm going to call this side length here, which I do not know, I'm going to call that x. I'm going to call this CD, the other side there, I'm going to call that 13 minus x, because that's what it would be in terms of x, given that the entire length of AC is 13. So according to the triangle-angle bisector theorem, I can say 10 over x will equal to 16 over 13 minus x. And all I got to do is just cross multiply. So I do 10 times 13 minus x is equal to 16x. Multiply the 10, I get 130 minus 10x is equal to 16x. Add 10x to both sides, I get 130 is equal to 26x. Divide both sides by 26, x will end up equaling to 5. If x is equal to 5, I can then figure out what the side lengths of of AD and CD is. So AD is going to be 5, and CD is going to be 8. Okay, pause the video here to see if you can apply, see if you can figure this out. Hopefully you guys had some time to think about this, so let's go over it. So here, this question is set up prime for us to use this side-splitter theorem. So based on the diagram here, okay, I recognize that the uy and vx are parallel, so therefore these side lengths are parallel, and as well as st. So all these sides here are parallel. So if I know all these sides are parallel, okay, and I recognize that, and I also recognize that these lengths over here, that this length is, hold on, let me lower, that this length here is twice as long as that length there. So therefore, what that implies is, according to the side-splitter theorem, okay, this must be 2, because UV must be double that of WV, okay? And according to the side-splitter theorem again, if I know that UV to UT is equal to 2/3, I also know that XY to SY will also share the same proportion, but I already know what XY is. It's 5, right? And the goal is to find out what SY is. So SY, therefore, so I can say that 5/2 is equal to 5 over SY. Or SY, therefore, is equal to 15/2, which is 7.5. Next, I got to figure out what is UY and XV, okay? So I need to know what UY and XV is. So according to this, okay, I can now set up a series of proportions here. I cannot use side-splitter theorem because here I'm dealing with the segment, the length of the parallel segment there, right? So what I'm going to do is I am going to set this up and say, well, since I know the overall length, right, is ST is 12, okay, and since I know that the overall length ST is 12, and I know that the overall length TW is 6, right, so I know that TW over ST is equal to 6/12, okay? So that means all the other triangles, okay, must share this proportion. Okay, so I need to now figure out what UY is, okay? So UY, therefore, okay, or actually, no, I'm sorry, not UY over. I can then say UW over UY will also equal to 1/2 here. But what exactly was UW? UW is 3. And I'm trying to figure out what UY is. So I can say UY, so I can say then 6/12, or 1/2, is equal to 3 over UY, leading me to the conclusion that UY is equal to 1.5. All right. Alternatively, okay, I can also use the same approach to figure out what is XV. So therefore, again, I can say WV over XV, one more time, is equal to 1/2. How do I know it's 1/2? Well, it's because of 6/12 here, right? So again, WV over XV is equal to 1/2. But again, I know what WV is. WV is 1, right? So if WV is 1, XV, therefore, must equal to 2. And there you go. Okay.